Hello students, I am Karishma from SolveView and today I am going to discuss the topic of Lagrange method of undetermined multiplier. So students, here we will suppose that we require to find the maximum and minimum value of function f of x comma y where x, y, z are subject to constraint equation which is g of x, y, z equal to 0. Now here we will define a function capital F of x, y, z comma lambda that is equal to small f of x, y, z plus lambda times small g of x, y, z, and let's mark it as equation number 1. Here lambda is called Lagrange multiplier which is independent of x, y and z. So now the necessary conditions for a maximum and minimum are, here we will find the first order partial derivatives of function capital F with respect to x, then with respect to y and then with respect to z, and after that we will substitute these derivatives equal to 0 and mark them as equation number 2, 3 and 4. So students, after putting the values of partial derivatives equal to 0, we will get 4 equations and we need to find 4 unknowns, that is lambda, x, y and z. After finding these values, we will get our point, that is x, y, z, and this method is also applicable in case we have more than one constraint equations connecting the variables. So let's discuss one example related to this concept. So here we need to find minimum value of x square plus y square plus z square subject to the condition 1 upon x plus 1 upon y plus 1 upon z equal to 1. So that means this is our function small f of x, y, z, and this is our function small g of x, y, z. So let's start the solution. So students, here we have given f of x comma y comma z that is equal to x square plus y square plus z square, and the constraint equation is g of x comma y comma z that is equal to 1 upon x plus 1 upon y plus 1 upon z minus 1. Clear? Now we will define the function capital F of x comma y comma z comma lambda, and that is equal to f of x comma y comma z comma lambda, and that is equal to f of x comma y comma z plus lambda times g of x comma y comma z, where lambda is the Lagrange multiplier which is independent of x, y and z. So let's substitute the value of small f and small g. We get that is equal to x square plus y square plus z square plus lambda times 1 upon x plus 1 upon y plus 1 upon z minus 1. Clear? And we need to mark it as our equation number 1. So this is the value of our function capital F. Now we need to find partial derivatives of function capital F with respect to x, y and z, and after finding these values we will put them equal to 0. So here firstly I will differentiate capital F with respect to x, and it becomes 2x plus lambda times minus 1 upon x square, right, and this is equal to 2x minus lambda upon x square. Now I will differentiate capital F with respect to y, and that is equal to 2 times y plus lambda times minus 1 upon y square, that is equal to 2y minus lambda upon y square. Clear students? So now we will differentiate capital F with respect to z. So partial derivative of capital F with respect to z is equal to 2z plus lambda times minus 1 upon z square, and that will be equal to 2z minus lambda upon z square. Clear? Now we will put the value of these partial derivatives equal to 0. So let's divide the board. So here when I will put del f upon del x equal to 0, so this implies 2x minus lambda upon x square equal to 0, and this implies 2x is equal to lambda upon x square, right? Now from here this implies x cube is equal to lambda upon 2, and from here I got the value of x as lambda upon 2 whole raised to power 1 upon 3. Clear? Now similarly I will put partial derivative of f with respect to y equal to 0. So this implies 2y minus lambda upon y square equal to 0, and this implies 2y is equal to lambda upon y square. So from here we get that y cube is equal to lambda upon 2, and this implies y is equal to lambda upon 2 whole raised to power 1 upon 3. Now I will substitute partial derivative of f with respect to z equal to 0. So this becomes 2z minus lambda upon z square equal to 0, and this implies 2z is equal to lambda upon z square. So from here we get z cubed is equal to lambda upon 2, and this implies z is equal to lambda upon 2 whole raised to power 1 upon 3.
So here you can see that value of x is lambda upon 2 whole raised to power 1 upon 3. Value of y is also lambda upon 2 whole raised to power 1 upon 3. And value of z is again the same, that is lambda upon 2 whole raised to power 1 upon 3.
So here you can see that the value of x, y and z is same. That will imply that x is equal to y is equal to z. So now here you can see that the value of x is equal to value of y is equal to value of z. Now I will put this condition in our given constraint equation G. So that is 1 upon x plus 1 upon y plus 1 upon z is equal to 1. Here I will put y and z equal to x. So it becomes 1 upon x plus 1 upon x plus 1 upon x equal to 1, and this implies x is equal to 3, right? And you can see here that x is equal to y is equal to z. So from here we can say that our point x comma y comma z is equal to 3 comma 3 comma 3, and this is the point of minimum. Now we will evaluate the value of function at this point after substituting the point 3 comma 3 comma 3 in our function x square plus y square plus z square. So here f of 3 comma 3 comma 3 will be equal to 3 square plus 3 square plus 3 square, and that is equal to 9 plus 9 plus 9, and that is equal to 27. So this is the minimum value of our given function. So students, I hope that every step is clear to you, and if you want me to discuss more examples related to this concept, then you can visit our website, that is www.solvio.co.in, and thank you so much for connecting with us.